Let us start the fluid mechanics questions, FM1 questions for morning session in civil paper. Let us look at the first question now. The first question happens to be from hydrostatics, hydrostatic forces on curved surfaces. The question says, a cylinder 2 meters in diameter, 3 meters long and 25 kilonewton weight is acted upon by water on one side. You can see over here, there is water present on one side, and an oil on other side having a specific gravity of 0.8. The absolute ratio of net magnitude of vertical forces to the net magnitude of horizontal forces rounded off to 2 decimal places is how much? So the question over here is, what is the ratio of vertical force mod of to horizontal force? This ratio is equal to how much? This is a question. So let us write the given data first of all. Given data. We already know S of water is supposed to be equal to 1. S of water is supposed to be equal to 1. S of oil is supposed to be equal to 0.8. Fine. And he has given us the weight of this cylinder is equal to 25 kilonewton. Diameter happens to be equal to how much? Diameter over here is equal to 2 meters, and the length is equal to 3 meters. All this is given. We are supposed to find out this value of vertical force by horizontal force in magnitude is equal to how much? Let us start. First of all, I will start with horizontal forces. They are relatively easy to calculate, right? What I am going to do in this question is, I am going to use gamma of water as gamma equal to 9.81 kilonewton per meter cube. This is the value of gamma of water I am going to use. The most accurate value, since he has not given me anything, I will try to be as accurate as possible. You could use 10, but 10 would become slightly far away from accurate value. Therefore, preferably the accurate value over here. Let us start. I realize that there are two forces now in horizontal direction. One is water pushing towards the right hand side. One is oil pushing towards the left hand side. So let us get back to the diagram. Let us say water is applying some force over here. This is horizontal force by water, and over here I am having horizontal force by oil. I hope all of you recall that horizontal force is having the formula gamma into area times h bar for projected area, right? Please mind you that the interface is starting from here. The interface is starting from here. So the value of h bar for water is supposed to be at this location, that is equal to 1 plus half of 2, that is equal to 1 meter. 1 plus half of 2. In total it is going to be equal to 2 meters. The value of h bar over here is equal to 0.5 meters. Let us start now. The horizontal force by water, I am writing, is equal to gamma of water into area times h bar of projected area. Gamma of water, let us say, is equal to gamma. Area. Now look over here. If I look from the side view, I am going to see the height equal to 2 meters and the width perpendicular to the screen equal to 3 meters. Therefore, area over here is supposed to be equal to 2 meters times 3 meters, right? And h bar of projected area, we have already discussed, this value of h bar is equal to 2 meters. It is equal to 2 meters. So this net value is going to be equal to 2 times 2, 4 times 3 is equal to 12. So 12 gamma. The direction is important for us at this stage. Let us say it is in this direction. 12 gamma in this particular direction. Moving further, let us now talk about the horizontal force by the virtue of oil. It is supposed to be gamma of oil multiplied to area times h bar projected. Now this is equal to. Now I know that the specific gravity of oil is equal to 0.8. Therefore, I'll write this as 0.8 gamma times. Area I know, look at this. Area I know is equal to 1 times 3. So I can write 1 meters by 3 meters is the area. H bar, we have discussed this already, it is equal to 0.5, half of this thing. So it is equal to 0.5 meters. It is equal to 0.5 meters. Fine. Now, I am going to get the answer in terms of gamma again. So this value, let us say, F horizontal by the virtue of oil is equal to 0.5 times 0.8 is 0.4. 0.4 times 3 is equal to 1.2. So this is going to be equal to 1.2 gamma. 1.2 gamma. Mind you, the direction sense over here is in this direction. Now what happens? If I have direction sense in this direction, I can say the net value of horizontal force, summation of force horizontal happens to be equal to 12 gamma minus 1.2 gamma, which is going to be equal to 10.8 gamma. 10.8 gamma in this particular direction. Let us mark this as some equation number 1. I have got the value of horizontal force now. Half the job is done. The second half is regarding the value of vertical force. Let us start. The vertical forces. Now mind you, if I look for the vertical force, this kind of question has been done already by us in our classes. If you look for the vertical force, I am dividing this into 2 parts. One part which is experiencing water pressure, the other part which is experiencing oil pressure. I know that this entire portion is experiencing downward thrust and upward thrust by the virtue of water pressure. The resultant thrust is going to be upward. Corresponding to this much of volume. Okay. Next thing. In this particular side, the oil side, the vertical thrust is again going to be upward. Corresponding to how much of volume? Corresponding to, let me mention one second. Corresponding to this much of volume. I hope this volume things is clear to all of you. Now let us apply this. Thing. I am going for the new slide now. Let us say the vertical thrust by the virtue of water is supposed to be equal to how much? We all remember the formula. It is supposed to be gamma times volume, is it not? So gamma of water multiplied to volume. Okay. Now gamma of water we know is equal to gamma. What about volume? Please understand, this volume over here is cross section area multiplied to the width emerging out from your screen. So cross section area is equal to how much? Think logically, it is half a circle. Half a circle is pi by 8 d square, is it not? Pi by 8 d square multiplied to width. Width happens to be 3 meters. So let us say it is pi by 8 d square multiplied to the width coming out. If I put in the numbers, I have gamma into pi by 8. Diameter, as we know, is equal to 2 meters. Width over here is equal to 3 meters. Width over here is equal to 3 meters. So I have the value of vertical thrust by the virtue of water is equal to how much? Now you see, this and this cancels off, leaves a 2 behind, 2 at the bottom, 3 over here. So I have 3 pi by 2, 3 pi by 2 gamma in the upward direction. This is in the upward direction. Moving further to the vertical thrust by the virtue of oil. The formula shall remain the same. The formula will not change at all. That is gamma of oil this time around multiplied to volume. Gamma of oil times volume. Gamma of oil, need not to mention again, it is equal to 0.8 gamma. Now volume is equal to how much? Again, cross section area multiplied to the width emerging perpendicular to the screen. Cross section area, think logically without looking at the diagram. It was 1/4 of the circle, is it not? If it is 1/4 of the circle, I am supposed to have pi by 16 d square. Pi by 16 d square times width times width. So this is going to be equal to how much? 0.8 gamma, 0.8 gamma multiplied to pi by 16 d square. D is equal to 2. 2 square by 16 is going to give you pi by 4 over here. Pi by 4 multiplied to 3, so 3 pi by 4. 3 pi by 4. If you calculate this value, it is supposed to be equal to how much? I can have a 4 cancelled out point, that is equal to 0.6 pi gamma in the upward direction. In the upward direction. Now, if you see both of them in the upward direction, therefore I can say the net value of vertical thrust is supposed to be equal to this plus this, is it not? This, if you see, is 1.5 pi gamma. It is 1.5 pi gamma, and this is equal to 0.6 gamma plus 0.6 gamma. So you have over here net vertical thrust in the, sorry, we have not considered the weight yet. So let us say by the virtue of fluid is still equal to, one moment please. The vertical thrust by the virtue of fluids is equal to 2.1 pi gamma in the upward direction. Now consider the weight. Since he has given you the value of weight, let us also consider the value of weight to get the net vertical thrust. So net vertical thrust is equal to 2.1 pi gamma, 2.1 pi gamma minus 25 kilonewtons. Now don't worry, there will be consistency of units as long as you take the value of gamma as 9.81 kilonewton per meter cube. Okay, since I'm having kilonewtons over here, you're supposed to consider kilonewtons over here as well. Now let us look at the ratio. The question was asked regarding net value of vertical to net value of horizontal. So net value of vertical I'm having is equal to how much? Is equal to 2.1 pi times 9.81 minus 25 divided by horizontal value was equal to how much? Look at the previous slide. Horizontal value was equal to 10.8 gamma. That is equal to 10.8 times 9.81, right? Now if you calculate this value is going to come out to be equal to, this value is going to come out to be equal to 0.38. This value would come out to be equal to 0.38. This is your answer. This is the answer. The question was slightly lengthy, but don't worry. Since I'm explaining the answer, therefore it is looking that much lengthy. Otherwise, if you're just doing it, it won't look as lengthy, right? And one more important trick you're supposed to remember in these kind of questions is, whenever questions become these lengthy, okay, what have I done over here? You see, when the question was becoming this lengthy, I anticipated the question is going to become lengthy. So what I did not put in the value of gamma from the initial stage. I just kept it as gamma, because keeping on writing 9.81 and multiplying with 9.81 over and over again, right, it can induce some kind of mistake. This generally happens, okay. Therefore, what I did, I tried to keep everything in terms of gamma initially itself. And I put in the value, I substitute the value of gamma only at the last step, so as to avoid the induction of errors. Whenever answers become lengthy, these kind of things have to be done. Anyway, I hope the answer is clear. It is 0.38. Let us now move further to the next question. This is a very, very simple question actually. This is a question which you are supposed to know the answer by heart actually. Let us look at this. A liquid flowing steadily in a circular pipe of radius capital R has a velocity that is everywhere parallel to the axis, that is center line, okay, of the pipe. The velocity distribution along the radial direction is given by, the radial direction velocity is equal to capital U times 1 minus small r square, which is local radius, this is local radius, upon capital R square, which is the maximum radius, where small r is the radial distance as measured from the pipe axis and U is the maximum velocity at small r equal to 0, center line velocity basically. The average velocity of the fluid in the pipe is equal to how much? Now, why do I say this question is this easy? The reason is, this is a standard case. If you recall, this particular formula of velocity, the radial velocity equal to maximum times 1 minus small r square upon capital R square, is basically, this is basically laminar flow through pipes. Laminar flow through pipes. This is the velocity of laminar flow through pipes, right? And we know that in the case of laminar flow through pipes, the average velocity is equal to half of maximum velocity. This is something which you have memorized already. So straight away, without doing any calculation, I would expect in examination that you have taken the answer as answer capital U divided by 2. Still, if you want to get the answer by the conventional method, I'll do it now. Okay. The conventional method is, whenever you want to find out the average velocity, let us say I'm using U bar for average velocity. We can use V, we can use U bar also over here. I'm not preferring V because you have taken V something already over here. The value of U bar is equal to discharge upon area. Discharge upon area. But the problem is over here, how do I get the value of discharge? I can say the differential discharge over here. Differential discharge over here is equal to local velocity times differential area. Local velocity is VR times differential area. Then I would integrate this to get the value of complete discharge. Once I get the value of complete discharge, I would put in over here. I would use the area as pi r square. I would get the value of average velocity. Let us do that also. Now, I know that VR over here is equal to maximum velocity into 1 minus r square upon capital R square. What is the differential area you would have? This differential area is supposed to be a ring element inside that particular circular cross section. That ring element, if you recall, you have done this in mechanics, strength of materials, fluid mechanics, multiple times that ring element has come into picture. That ring element is going to have an area of 2 pi r, that is the circumference, multiplied to a differential thickness, which is dr. Now, I can say the value of differential discharge over here is equal to VR multiplied to differential area, that is capital U times 1 minus R square upon capital R square multiplied to 2 pi R times dr. 2 pi r times dr. If I wish to calculate the complete discharge, I'm supposed to integrate this thing. Let us take the constants aside. I have over here 2 pi, a constant, capital U, a constant. Let us say I'm taking r square. I'm taking, one second, not r square rather. Sorry, 2 pi and capital U are constants over here. And I'm taking divided by r square over here. So I'm going to have r square into r dr minus r cube dr over here. I'm supposed to integrate both these things. Ranging from where to where? From r is equal to 0 till r is equal to capital R. That is r is equal to 0 to r is equal to capital R. So if I calculate this value, this is a very simple integration. Okay, these are primary integrations, right? So you are going to have over here 2 pi maximum velocity upon r square multiplied to. Straight away I'm doing the integration and putting the limits also over here. I'm going to have r power 4 divided by 2. I'm supposed to have r power 4 divided by 2 minus. I'm going to have over here r power 4 divided by 4. If you calculate this value, if you calculate the value of discharge, how much are you supposed to get the value of discharges? You are going to have r power 4 by 4, 4 and 2 cancel off, leaving a 2 over here, and this is going to yield pi into u into capital R square divided by 4. 1 second, yeah, 2 rather, not 4, a 2 would remain. A 2. I have calculated the value of discharge. What now? If I want to find the value of average velocity, I would say discharge upon area. Discharge upon area, that is equal to how much? Pi capital U into r square by 2 whole divided by area is equal to pi r square. Cancel pi r square on either side, up and down. So therefore you're going to have average velocity is equal to maximum velocity divided by 2. This is a conventional derivation process of getting the value of average velocity in the case of laminar flow through pipes, which I assume or I hope you have not done all this entire work straight away. You knew that it was laminar flow through pipes. You knew that this U is your average maximum velocity and the average is supposed to be half of that. Therefore, the answer over here is equal to U by 2 or B option. I hope this is clear. Now, if you want to decide which topic this question is coming from, there are two options over here. It would come from kinematics also. These kind of questions can be a kinematic question. At the same time, this can be a question from laminar flow through pipes also. It is for you to decide which topic this question has come from. Moving further to the next question. Again, a very simple question, sort of, a giveaway kind of question. Okay, these kind of questions you can't miss out on, right? The question says kinematic viscosity is dimensionally represented by what? What are the dimensions of kinematic viscosity? Now, before I, answer is very simple, right? We can discuss, we don't need to discuss much on the answer. But before I go to the answer, let me tell you, any kinematic parameter is supposed to have m power 0. You take whatever kinematic parameter you are aware of. Always mass power 0 would be prevailing. You see velocity. The units are meters per second, dimensions length upon time. Right, you take acceleration, meters per second square. Whenever you have kinematic parameters, you are extracting out that inertia parameter, it is mass parameter. You remove the mass parameter, therefore you are supposed to have mass power 0. I see that both these two have mass, so these will not be the answer. Anyway, let us go for kinematic viscosity nu. This kinematic viscosity is supposed to have the units meter square per second. It is supposed to have the units meter square per second. Since it is meter square per second, it would dimensionally be equal to L square T power minus 1, which I see is option D over here. L square upon T is option D. Very, very simple question. With this, we conclude the questions in Fluid Mechanics 1. Thank you.